Using Statdisk for two-way analysis of variance. This video uses example 1 from section 12-3 titled Performance IQ Scores. Begin by selecting Analysis from the Statdisk top menu, then select Two-way Analysis of Variance from the drop-down menu. Enter the desired significance level, which in this example is 0.05. For the next three entries, refer to Table 12-3 in the textbook. Enter the number of categories for the row variable. In this example, we have two categories, male and female. Next, enter the number of categories for the column variable. In this example, we have three categories, low blood lead level, medium blood lead level, and high blood lead level. Now, enter the number of values for each cell. From Table 12-3, we see that each cell contains 5 values. Click Continue. Now refer to the table in the dialog box. This table contains 3 columns, row, column, and value. The columns labeled row and column have been populated with inputs based on our previous 3 entries. In this example, the column of row contains the category of sex for each data value. 1 equals male and 2 equals female. The column labeled column contains the blood lead level category for each data value. 1 equals low, 2 equals medium, and 3 equals high. We must now input the data values that correspond to each category entry. The data from Table 12-3 has been entered into the Statdisk sample editor using the same sequence of categories. Because the data values are in the correct sequence, we can copy and paste this data into the two-way analysis of variance dialog. With the data values now entered into the third value column, we can now click Evaluate to display the results. We begin by testing the null hypothesis that there is no interaction between the two factors. In this example, we get the F-test statistic of 0.43. The corresponding p-value for the interaction effect is 0.6547. Because this p-value is not less than or equal to a significance level of 0.05, we fail to reject the null hypothesis of no interaction between the two factors. It does not appear that the performance IQ scores are affected by an interaction between sex and blood lead level. There does not appear to be an interaction effect. For the row variable sex, the F-test statistic equals 0.0719. The corresponding p-value is found to be 0.7909. Because the p-value is greater than the significance level of 0.05, we fail to reject the null hypothesis of no effects from sex. That is, performance IQ scores do not appear to be affected by the sex of the subjects. For the column variable of blood lead level, we find the F-test statistic to be 0.0995. The corresponding p-value is 0.9057. Because the p-value is greater than the significance level of 0.05, we fail to reject the null hypothesis of no effects from lead level. Performance IQ scores do not appear to be affected by whether the lead exposure is low, medium, or high. In summary, based on these results, we conclude that performance IQ scores do not appear to be affected by sex or blood lead level.